Hello students. So in power system analysis, this is one of the important topic which is called the per unit system. So the use of per unit system is to simplify the power system calculations. So normally you will have the electrical quantities like voltage, current, and power, and some other parameters. That everything you will bring into the common base, right? So that is what per unit. So for example, uh, so here you can see the formula for the per unit system. So per unit value will be equal to the actual value divided by the base value. So for example, if you want to find out the per unit voltage, so the formula will be actual voltage to the base voltage. But the unit for the both numerator and the denominator voltages will be maybe in volt or kilovolt something, right? So this V and V will get cancelled here, and so finally you will get uh, some voltage value, the per unit quantity of the voltage. Some the unit will be in per unit, right? So this is what the common base value or the unitless quantity or the unitless quantity, right? And here you can see. So normally, the 1000 kVA is equal to 1 MVA. 1000 kVA is equal to 1 MVA. So here I am telling how to, if I have the data in MVA value, if I want to convert that into kVA, or if I have the kVA value, if I want to convert that into MVA value, what should I do? That I am telling now. So here you can see, already so 1000 kVA is equal to 1 megavolt ampere. So where the 1 kVA is equal to the 1000 MVA, so which is nothing but 1000 kVA is equal to 1 MVA. So where 1 kVA is equal to 1 divided by 1000 MVA, right? So, and if I have the data kVA, right? If I have the data in kVA, if I want to convert that into MVA, I have to divide that value by 1000, right? So if I have the values in kVA, if I want to convert that into MVA, I have to divide that value by 1000, right? If I have the value in MVA, if I have the value in MVA, if I want to convert that into kVA, I have to multiple with 1000, multiple with 1000. So that's it. So here you can see, if I want to convert that MVA to kVA, MVA to kVA. So MVA to kVA, already I told, you have to multiple 1000. MVA to kVA, you have to multiple 1000, and kVA to MVA. If we have the data in kVA unit, we have the data in kVA unit. If I want to convert that to MVA, I have to divide by 1000. So this is standard rule you have to remember. In problem we will use these terms, and the circuit formulas in per unit values for the single phase system. So in per unit apparent power is equal to actual apparent power to the base apparent power. So S to be SB. SB stands for the base apparent power. So apparent power. So V star, and this is SB. We take complex conjugate of the both side. V star divided by SB. So V divided by V star. So SB you can write in terms of VB into IB, right? So this S is equal to VA. So from this formula we can write instead of SB, VB, IB, right? So this looks like the actual value of voltage to the base voltage, and this is actual value of current to the base current. So the per unit voltage, and this is per unit current, right? So this is in the form of the per unit values quantity. So the per unit apparent power S per unit is equal to V per unit into I per unit. And in per unit voltage is just nothing but the actual value of voltage to the base voltage. So this can be written as instead of V you can write Z into I, so VB. So Z into I, instead of VB you can write VB divided by, sorry. So this can be written as multiple and divide by the term IB. So that the equation, the expression will become like this: VB divided by IB into IB. So this remains same. So this you can split and write. So Z divided by, instead of this VB IB you can write ZB, and this is same here, I divided by IB. So this is per unit impedance Z divided by ZB, and this is per unit current I divided by IB, right? So this is what the per unit voltage. So per unit impedance into the per unit current. And assume the common base values VB, SB, the remaining IB and ZB are computed from the following expressions. So IB is equal to SB divided by VB. So how this formula arrives. So where S is equal to VI. So from this you can write I is equal to S divided by V, right? So that is what they have written here. IB is equal to SB divided by VB, and ZB is equal to what? And here you can see ZB, the base impedance is equal to VB divided by IB. So this can be written as VB divided by IB. So multiply and divide by the term VB and VB. So this can bring like this: VB square divided by SB. So the impedance in per unit you can write, the standard formula, actual value of impedance to the base value of impedance. So you can write Z divided by ZB, where ZB already you have the data, what it is. VB square divided by ZB, right? Already you know ZB is equal to VB square divided by SB. So that they have replaced here. Instead of ZB, VB square divided by SB. So that you can write like this, Z divided by VB square into SB. So now you will get the formula for the per unit impedance. Z per unit is equal to Z divided by. So if the values are in voltages are in kV and the apparent power in MVA, so you can write the formula Z divided by KVB square into MVAB. So here you can see if VB in kV and SB in MVA, right? Then so finally if the SB values in kVA, so already I told this, if the values are in kVA you can convert, if you want to convert that into MVA, you have to divide the value, the kVA value by 1000, right? So that they have uh, done it here. Z per unit, Z divided by kVB square into kVA base divided by 1000. So this whole value now it is converted to MVA base, right? So normally the base values are you can bring into MVA. So that is what they have done here in three-phase circuit. So now this is all about the single-phase circuit. In next class we'll see about the three-phase circuit.